Welcome you all. In this session, we will discuss the problem based on second law of thermodynamics. In this problem, a reversible heat engine operates between 600 degrees centigrade and 40 degrees centigrade. This engine drives a reversible refrigerator operating between 40 degrees centigrade and minus 18 degrees centigrade. Still, there is a net work output of 370 joule. The heat received by the engine is 2100 kilojoule. Determine the cooling effect. Right? So in this problem, there is a reversible heat engine. Right? So this is very important. Reversible. This is a reversible heat engine. Operates between 600 degrees centigrade and 40 degrees centigrade. This reversible heat engine operates between 600 degrees centigrade and 40 degrees centigrade. This engine drives a reversible refrigerator. This heat engine drives a reversible refrigerator operating between 40 degrees centigrade and minus 18 degrees centigrade. This reversible refrigerator operates between this 40 degrees centigrade and minus 18 degrees centigrade. And it gives net work output of 370 kilojoule. It gives net work output of 370 joule. Right? The heat received by engine is 2100 kilojoule. This is the quantity of heat received by the reversible heat engine. This is 2100 kilojoule. Determine the cooling effect. Okay, this is the cooling effect. This is refrigeration effect. Okay, so this is all about the problem we have to solve. In this problem, we have to find the cooling effect or refrigeration effect. Okay. So in this figure, this is a reversible heat engine. This reversible heat engine withdraws 2100 kilojoule of heat from a reservoir having temperature 600 degrees centigrade. This heat engine delivers W1 amount of work and rejects Q2 amount of heat at minus 40 degrees centigrade. This W amount of work, out of this, some amount of work is utilized to run the refrigerator and it delivers 370 joule of work. This work input W2 is used to run the reversible refrigerator. This reversible refrigerator extracts Q3 amount of heat from lower temperature reservoir and Q4 amount of heat is rejected to higher temperature reservoir which is at 40 degrees centigrade. Now we have to find the quantity of this Q3, this refrigeration effect. This is all about the problem, right? Well, now in this problem, first of all, we know that this refrigerator is reversible refrigerator. Well, this is reversible refrigerator, and we know this COP of this reversible refrigerator is equal to lower temperature divided higher temperature minus lower temperature. This is the formula of COP of reversible refrigerator, and this can be written. This can be equal to desired effect. This is Q3 divided work input. This work input, and this Q3. You know this work input is here W2. Right? This COP of reversible refrigerator. Okay. We know this lower temperature and higher temperature. This lower temperature is minus 18 degrees centigrade and higher temperature is 40 degrees centigrade. Therefore, we have to put this value in this equation. After putting this value, we have this Q3 by W. This Q3 by W is equal to, this is equal to 4.396. Right? Okay. Now, this W1 is the work output by this engine, reversible heat engine. Well, this W1 is equal to this Q1 minus Q2. It is clear because this Q1 is equal to, from this equation, this Q1 is equal to this Q1 is equal to W1 plus Q2, right? Therefore, this W1 is equal to Q1 minus Q2. So this is the equation, W1 is equal to Q1 minus Q2. Okay, and we know that for reversible cyclic engine, this Q1 by T1 is equal to Q2 by T2. This is important equation. We know this one. Okay, this is the temperature scale equation. This Q1 by T1 is equal to Q1 by the latest number. This is T1 and this is T2. Okay, this Q1 by T1 is equal to Q2 by T2. This is only for reversible cycle. Okay, so therefore this Q2 is equal to Q1 into T2 by T1. This Q1 is given 2100 kilojoule of heat is extracted from T1. This Q1 into T2 is 313 and T1 is 873. After putting this value, we will get the value of Q2. This Q2 is found out, right? This Q2 is 752.9 kilojoule. So from where this Q1 is given, this is 2100 kilojoule and Q2 has been calculated. This is 1347. This is 752.9 kilojoule. Therefore, this W1 can be calculated. This W1 is equal to 2100 minus 752.9. This is 1347.1 kilojoule, right? So this W1 is calculated. Okay. Therefore, we know that this W net is equal to, this is given 370 kilojoule. The W net. So from this equation, this W1 is equal to W2 plus W net, right? From this equation, this W1 is equal to W2 plus W net. This implies W net is equal to W1 minus W2, right? So this is equation is written here. W net is equal to W1 W2. This is equal to 370 is given. This W1 we have calculated. So from where this W2 is equal to 977.17 kilojoule. Therefore, we have already equation this, we have find out this Q3 by W2 is equal to 4.396. We have calculated in previous slide. From here, this cooling effect Q3 is equal to 4295.2 kilojoule, right? So in this problem, this cooling effect, this is refrigeration effect is in kilojoule. This 4295.2 kilojoule. This is the answer of this question.